so good day again. So this time we're going to solve sample problem number 2. Solve for the deflection at point B of the beam shown. So as you can see from the given problem, we have a simple beam with a concentrated load of 30 kN applied at point B. Point B is 2 meters from the left support and 4 meters from the right support. So meaning the concentrated load is not applied at the midspan. And we are asked to determine for the deflection at the point of application. So delta. Elasticity and inertia of the beam were given. Okay, so as we can see from this example, the beam is determinate. So meaning we can solve for the reaction. If we take moment at point C, we can solve this reaction 20 kilonewtons. If we take moment at A, we can solve for this reaction 10 kilonewtons, or summing up forces vertical, we can solve for these reactions. No? So, hindi ko na ipakita kung paano sinolve yung reactions 20 and 10. Okay, so we can solve for this deflection delta over here using 3-moment equation. Okay, so we will consider. So, let us consider points A, B, C. So, let us consider A, B, C. Points A, B, C. So, using the 3-moment equation, okay, so this one, the general equation, so we'll have so MA, we have MA L1 plus twice MB L1 plus L2 plus, okay, so MC times L2 plus the 6AA over L1 plus the 6AB over L2 equals, okay, so we have 6EI times H1 is the movement of point A with respect to B. That is HA over L1 plus H3 is the movement of point C with respect to B. So that is HC over L2. Okay, so isa-isahin natin, no? Okay, the moment at A 0, 'di ba? Kasi dulo ng beam, tapos hinge siya, tapos wala namang external moment na naka-apply doon. So this would be just 0. Okay, yung MB is unknown. MC, the moment at point C, dulo ng beam roller, but wala naman siyang external moment applied there. So this would be also 0. Paano ulit yung AA? Diba yung AA is corresponding for L1. L1 is yung 2 meters. So kung i-isolate mo yung 2 meters, gawin mo siyang simply supported, wala namang siyang load within the beam. Ang load lang natin doon yung 30 nasa support na. So therefore, this would be also 0 din. Wala namang isang other load. Likewise, yung AB, considering L2, ito yung L2, wala namang other load within L2, diba? So therefore, this would be also 0. Now, 6EI, so we have there the EI. Then, HA, ano yung HA? Okay, so, ano yung HA? This is the movement of point A with respect to point B. So, due to this 30 kN load, this would be the final point of B. So, ibig sabihin, may movement yung A, may movement yung A with respect to B. So, hindi to 0. No, hindi to 0. Actually, the movement of A with respect to B is yung delta. So this would be delta. How about yung HC? Yung movement ng C with respect to B rin. And that is also actually delta. Delta rin yan. Now, anong sign convention ng delta natin dito? Diba sabi natin, ang sign convention natin sa delta, sa H1 at sa H3, it would be positive kapag yung movement is downward. And it would be negative if it is an upward settlement. So kung titingnan mo yung point A with respect to B, para siyang tumaas, umangat. Ito yung B, yung A nasa taas. So para siyang umangat in reference with B, umangat. So umangat means upward, kaya negative yung delta natin dito. Likewise, yung sa point C rin, in relation with point B, yung point C para siyang umangat in reference with point B. So, umangat, upward means negative din yung delta. Okay, so let us simplify the equation. So, this would just be 0. We have 2 MB, okay, 2 MB times L1 plus L2. 2 plus 4 is 6. Okay, 0, 0, 0 is equal to 6 EI. Then times negative delta over L1 is 2 plus HC is negative delta again over L2. L2 is 4. So this would be our equation. Now substitute. So what is MB? But since the beam is determinate, we can solve easily the moment at B, right? So what's the moment at point B? O di cutting section, i-cut natin dito. So pag kinat natin section dyan, the moment at B would be simply 20 times the moment arm of 2. 20 times 2. Okay? 20 times 2. Now, ano yung totoong sign convention na moment? Ano yung moment natin? Okay, so that is the direction of moment. So what that 20 kilonewton, so pag ganun, no? So pag ganun, so it makes the beam smile. So therefore this would be positive 40 kilonewton meter. Okay, so substitute again here. So this would be 2 times 40 times 6 is equal to 6 EI. E is 200 GPa. Okay? Yung I na lang, i-convert natin kasi yan sa meter square para maging consistent dito sa meter square. So, what I'm going to use na lang is 50. Kasi yung times 10 to the 6 niya will be cancelled out with the conversion factor na mm square to meter square. Okay? So, times this one. So this would be negative 1/2 plus 1/4 is 3/4. 3/4 of delta. Okay, so from this equation, we could solve now for delta. So that would be 2 times 40 times 6. Okay, divided by 6, divided by 200, divided by 50, times 4 divided by negative 3. So our delta is negative 0.01067 meters, or that is negative 10.667 millimeters. And the negative sign here, that the deflection is downward. Okay, so that is our answer. 10.667 millimeter downward. Okay, so I hope you understand this simple solution for deflection using 3 moment